Have you ever pondered the importance of the invisible shield that keeps us alive? It's a question that might sound like it comes straight from a science fiction novel, yet it's far from it. This invisible shield is real, and it's known as the ozone layer. Imagine a thin, delicate blanket wrapping the Earth. This blanket, invisible to the naked eye, is a layer of gas containing a high concentration of ozone, a molecule formed by 3 oxygen atoms. This gaseous layer forms part of our atmosphere, sitting approximately 6 to 10 miles above the Earth's surface in what we call the stratosphere. What makes this ozone layer so crucial? It plays a pivotal role in safeguarding life on Earth. One of its main functions is to absorb most of the sun's harmful ultraviolet radiation. Without this protective layer, these deadly rays would reach the Earth's surface, causing a myriad of health problems for humans and other life forms, such as skin cancer and cataracts in humans, and hindering the growth of phytoplankton, the backbone of our ocean's ecosystems. But that's not all. The ozone layer also contributes significantly to maintaining the Earth's temperature. It absorbs the ultraviolet rays from the sun, transforming them into heat, thus keeping our planet warm enough to sustain life. In this sense, the ozone layer acts as Earth's thermostat, regulating the planet's temperature and maintaining the delicate balance necessary for life to thrive. So, when we talk about the ozone layer, we're not just discussing some abstract scientific concept. We're referring to a critical component of our planet's life support system, the invisible shield that makes life on Earth possible. Without it, the world we know, with its rich biodiversity and climates, would be unrecognizable. We are only just beginning to grasp the true significance of this invisible shield. As we delve deeper into this topic, we'll explore the history of ozone depletion, the culprits behind it, its consequences, and the road to recovery. Without the ozone layer, life as we know it would be drastically different. The story of the ozone layer's depletion is a tale of human intervention. It's a narrative that begins in the heart of the Industrial Revolution, a period of rapid industrial growth that spanned the late 18th to the early 19th century. This era saw a dramatic increase in the burning of fossil fuels, releasing vast amounts of carbon dioxide and other greenhouse gases into the atmosphere. However, it wasn't until the early 20th century that we introduced a new player to the scene, chlorofluorocarbons, or CFCs for short. These chemical compounds were first synthesized in the 1920s and quickly found widespread use in a variety of applications, from refrigeration to aerosol propellants. CFCs were hailed for their stability, non-toxicity, and non-flammability, seemingly perfect for human use. Little did we know their very stability would ultimately prove to be a double-edged sword. Fast forward to the 1970s, when scientists began to suspect that something was amiss. They theorized that CFCs, upon reaching the upper atmosphere, could be broken down by solar radiation, releasing chlorine atoms. These atoms, in turn, had the potential to catalyze a destructive reaction, breaking down the ozone molecules. This theory was confirmed in the mid-80s, with the shocking discovery of a massive hole in the ozone layer over Antarctica. This was our wake-up call. The ozone hole, a direct result of CFC-related depletion, was a stark, tangible sign of the damage we had inflicted on our planet's protective shield. The international community reacted swiftly. In 1987, the Montreal Protocol was signed, an international treaty designed to phase out the production of numerous substances responsible for ozone depletion, including CFCs. This marked a significant step towards addressing the issue, but the damage had already been done. And thus, the once protective shield began to weaken, leaving us more exposed than ever before. This is not just a story of depletion, but a cautionary tale of human intervention, reminding us of the profound impact our actions can have on the world we inhabit. So, what exactly caused this shield to deteriorate? The answer lies in a tale of human ingenuity, where the very solutions we created for our comfort and convenience became the culprits of ozone layer depletion. The major offenders in this narrative are a group of compounds known as ozone-depleting substances, or ODS for short. Chief among these are chlorofluorocarbons, more commonly referred to as CFCs. Invented in the early 20th century, CFCs were seen as a miracle of modern chemistry. Non-toxic, non-flammable, and incredibly stable, they found widespread use in everything from air conditioners and refrigerators to aerosol cans. However, it was this stability that turned out to be a double-edged sword. Once released into the atmosphere, CFCs could remain for years, slowly drifting upwards towards the stratosphere. Here, under the intense ultraviolet radiation of the sun, these harmless-looking compounds underwent a transformation. They broke apart, releasing chlorine atoms, which then catalyzed a reaction that destroyed ozone molecules. And it wasn't just CFCs. Other synthetic compounds, such as halons used in fire extinguishers, also played a part in this destructive process. Even certain types of industrial solvents and agricultural fumigants have their share of the blame. Each of these compounds, in their own way, contributed to the thinning of our protective ozone layer. It's a bitter irony, isn't it? The very substances that we created to make our lives easier, safer, and more comfortable were the ones that put us in harm's way. Our refrigerators kept our food fresh, but at the cost of our atmosphere. Our air conditioners kept us cool, but they warmed the planet. Our aerosols delivered our perfumes and paints, but they also delivered destruction to the ozone layer. In essence, the culprits of ozone depletion were not some alien invaders or natural disasters, but the products of our own hands, our own minds. Our own inventions turned against us, jeopardizing our very existence. The thinning of our ozone layer isn't just an environmental issue, it's a threat to all life forms. Imagine a world where stepping out into the sun is akin to exposing oneself to a perilous downpour of harmful radiation. This is the reality we face as our ozone layer continues to deplete. The consequences are far-reaching and affect not just us, but the myriad of life forms that share our planet. The most immediate impact is on our health. Increased exposure to ultraviolet or UV radiation due to the thinning ozone layer has led to a surge in skin cancer cases worldwide. This isn't just a few extra doctors' visits, it's a matter of life and death. But the damage doesn't stop at skin cancer. UV radiation can also cause cataracts, a clouding of the lens in the eye that leads to a decrease in vision. It's like living in a world that's gradually fading to white. Our immune system isn't spared either. Exposure to UV radiation can weaken our body's defense mechanisms, leaving us more susceptible to diseases and infections. It's as if our biological armor is being chipped away piece by piece. The effects of ozone depletion aren't limited to humans. The ecosystems we share with other life forms are also under threat. UV radiation can hinder the growth of phytoplankton, the microscopic plants that form the base of the ocean's food chain. This can lead to a domino effect, disrupting the balance of life in our seas and oceans. On land, certain species of amphibians have been seen to suffer. Their eggs, laid in shallow waters, are particularly vulnerable to increased UV radiation. The result? A decline in their populations, adding another note to the somber symphony of biodiversity loss. The consequences of ozone depletion are not just paragraphs in a textbook, they are real and tangible. Each one of us, from the smallest microorganism to the largest mammal, feels its effects. Let's not forget, the price of a depleted ozone layer is paid by every living organism on this planet. Is there a light at the end of this tunnel? One might ask. Well, it turns out there is. And it's not just a speck of light, but a promising glow of hope. In the late 20th century, the world came together in an unprecedented show of unity. The Montreal Protocol, signed in 1987, was a global agreement to phase out the production and consumption of ozone-depleting substances, or ODS. It was a significant step, a line drawn in the sand by humanity, signaling our commitment to the planet we call home. And the results? They've been nothing short of extraordinary. Since the implementation of the Montreal Protocol, the production of ODS has dropped dramatically. We've seen a decrease in the release of harmful chemicals like chlorofluorocarbons or CFCs, which were once widely used in refrigeration and aerosol products. But the road to recovery is not an overnight journey. The ozone layer recuperates at a gradual pace. It's a slow process, yet it's happening. Scientists estimate that if we stay the course, the ozone layer could return to its pre-1980s level by the middle of this century. What does this mean for the future? It's a testament to the power of collective action. It's evidence that when we come together as a global community, we can reverse even the most daunting environmental challenges. But the job isn't done, not by a long shot. We must remain vigilant in our efforts, continuing to phase out ODS and invest in sustainable alternatives. We must educate each other about the importance of the ozone layer and the role it plays in protecting life as we know it. While the road to recovery is long, our collective actions can ensure a safer future for all living beings. We've seen the first steps towards this future. Let's continue the journey together, for our planet, for our future, for all life on Earth, on the